firstly, try to understand that time is relative. Okay, time is always relative. So essentially, right? I think one of the problem with this question is students will put like something like that. They put 10 a.m. This is 10 a.m. right? Then they put the standard deviation here lah. Okay, which is not correct. You know why? Because this time is this time 24 international time, right? There's hour and also there's minutes, ma. You can't just read off like that. Okay, so you need to create a system lah. So what I'm saying is, say for example, you just reset your t equals to 0. Let's t0 is 10 a.m. Okay, so let's say t equals to -5 would be what? It corresponds to what time? If my t is in minutes, this will be 0955. Understand? So you create. So this t when it's 2 p.m. what would the t correspond to? It correspond to 4. This is 4 hours, right? Times 60 lah. So it's 240 minutes. Understand? So this is 240 minutes. Just that's the case. You time is relative. You set 0. The best time to set is anchor at 10 a.m. Then it's not so confusing, man. So we let that be. So let's say if I got t equals to 100 and 100 minutes, this would then correspond to 11 and 60. 11:40 a.m. right? You understand what I'm saying? So you just anchor your time t equals 0 at 10 a.m. That's the main thing there. Okay, so that's the first thing to tackle. So create a time system. Time is relative. Then the other thing is this: departure time has a normal distribution with a standard deviation of 3 minutes. What does this mean? It's a curveball, right? How come the departure time got 3 minutes there? The standard deviation, because you can think of it as this train, okay, can leave early or leave late. Let's say if the train passengers are all up already, right? You before 10 a.m. all the passengers are there, then you can just leave early lah. So that's the whole idea, right? But at the same time, if you are waiting for passenger to arrive, you can leave later lah. So essentially, this just say that you have this 3 minutes standard deviation at the start departure time. You just center it as 0 and then 3 square lah, standard deviation. So your departure, just understand that you may leave early or late based on the situation, right? Journey time is quite straightforward lah. Journey time, okay, the minutes also, right? Journey time is you on average you will take 234 minutes to travel, and then 4 standard deviation of 4 square. So hence the distribution of arrival time will be what? You let A be the arrival time in minutes after 10 a.m. So then A will be A is basically you add the departure time plus the journey time. Is that okay? That's what you do, right? You essentially you need to decide what time you leave train station A. The departure time has a standard deviation of 3 minutes. Okay, then your journey time, you just add it up. You just put from 10 a.m. Okay, so from 10 a.m. So that's that. So A equal D. So this will just be normal distribution 2, 3, 4. 3 square plus 4 square, that will be 25. Okay, that's a distribution of arrival time. So the lesson is basically understand that time is relative. Usually this kind of question, you have to have an anchor point. You set 0 at a certain time, then you just measure from there. Okay, don't put the time. Don't put the time in the mean there, because it doesn't make any sense. How to visualize this? Is very okay. We try and visualize this. This arrival time is centered about 2, 3, 4 minutes. 2, 3, 4 minutes will correspond to what time? 2, 3, 4. 2, 4. Is 2:40 minutes is 2 p.m. Then this 2, 3, 4 will be 6 minutes later. 56, 54. 1, 3, 54. Essentially, now the way you look at this is that this normal distribution looks like that. You go up, come down. Okay, this is the arrival time. On average, you will reach 1:54 p.m. Okay, so being late will mean that you this is being late means actually you take more than 240 minutes, 240 minutes to travel the arrival time. That's it. Okay, you key in calculator, you get the answer. There will be key in. You have normal CDF. Lower is 240. Upper is 10. Then mu is 234. Then this will be 25. 0.115069. Great. I think this is the answer. Part C should be okay. Part C, then you have 10 consecutive journey. The train will be late at least once. You can either use binomial or just use normal probability. Okay. So this case will be at least one. You just name your binomial. Out of 10, every one journey will be late is 11.5%. So this is it. So 1 minus of PL equals to 0. In fact, you don't really need to use what they call it, the binomial. You can just do this out of 10. Okay, so that's it. Try to understand the question. Find the nearest minute, the earliest time to which the scheduled arrival time should be changed to, so that the probability that the train will be late is less than 0.01. Now, understand this, when you're late to something, time is relative. When you're late, right, means someone decided that you should start here. Right, you're late for school, right? School say this one is the time. Actually, what you can do is you just move the goalpost, you just start later, lor. Then everyone happy, the lesser people will be late. But so that's the whole idea. You set at 2 p.m. arrival time. It's either you start at 2 p.m. arrival time or you set off earlier. Okay, so but now they say you want to move this goalpost here, this 2 p.m. here, move it later, so that you have less than 1% of people being late. So you still use the same graph lah. So now if we set at T 240, this is the side lah. So now what we want is essentially we just want the arrival time already is the same, right? We instead of 240, we want this to be 0.01 cent, and then we want to find this time here being late. Understand? So now we want to find this time, this corresponding time with this A here. So just now we put 240. Now we want to put the A lah. We want 1%. So take note now, it's the right tail, not the left tail. You want the right tail here. The guy that you want. Fine. Okay, so now if let A be the new scheduled time. Now if P arrival time more than A is 0.01. So okay, let's just understand this. If it's exactly 1% being late, you can just inverse norm lah. You inverse norm, find out what is this A here, right? Here, you just inverse norm. So second inverse norm, 0.01. Then you put right lah. Okay, jalat. I need to key in the mean. So mu is 234. Then this will be square root 25, which is 5. 245. Okay. This is a time when it's exactly 1% journey being late. But if you want less than 1% journey being late, this will imply that PA bigger than A must be less than 0.01. So now the question is, should A move to the left or right to be less than 1%? It should be the. If you want this to be less than 1%, should A move to the left or right? To the right. Okay. Move to the right side. Because if A move to the right side, it will be lesser than that. So essentially what they're saying is you want A to be more than 245.6 minutes. Okay. So in fact, so hence least A is 246 nearest minute. You add this up, 24. Okay, this one is quite okay. 10 a.m. plus 246 minutes. So this will be 1406 hours. Okay. There will be 4 hours plus 6 minutes. So that's the new arrival time.